Greetings and welcome to the introduction to astronomy. In this week's discussion on the celestial sphere, we are going to look at right ascension and declination and see how they can be used to measure the coordinates of an object in the sky. So what are the right ascension and declination? Well, they are coordinates to tell us the position of an object in the sky. This is what we call the equatorial coordinate system, measured relative to the celestial equator. Now, if you recall, the celestial equator is the projection of the Earth's equator out onto the sky. Now we can measure coordinates like this, just like we did with the horizontal coordinate system. The declination, in fact, is very similar to the altitude. In this case, it is the angular distance above or below the celestial equator. And as you recall, the altitude was above or below the horizon. So they're very similar, and they range as the same from -90 degrees, which would be an object at the south celestial pole, to +90 degrees, which would be an object at the north celestial pole. And we look at our object here, and we're trying to measure the position of this star. The declination goes from the celestial equator, which is the line right here, and measures that straight upward toward the pole, toward the North Pole, or straight downward toward the South Pole. In this case, we would have a positive declination because we are up above the celestial equator. An object on the celestial equator, just like an object on Earth, would have a value of 0 for its declination. Now, the right ascension is similar to the azimuth that we looked at previously. It is the angular distance around the celestial equator, starting with the vernal equinox. So you remember, we started with the north point on the horizon for the azimuth. Now we're measuring relative to the vernal equinox. We have to pick some point at which to measure from. So the vernal equinox here is one of the two places where the celestial equator and the ecliptic cross. And in this case, it is when the sun is moving up above the celestial equator. So this is the first day of spring for those in the northern hemisphere. Now, then you measure that along the celestial equator, and that gives you the two coordinates you need. Two coordinates will exactly specify the location of any object in the sky. Now, right ascension does differ from azimuth is that it is not measured in degrees. It is traditionally measured in hours, with there being about 15 degrees in 1 hour. And that's about how long it takes an object to move across the sky. So in 1 hour, an object would move about 15 degrees, making a full circle of the sky in 24 hours. Now, the difference here with the altitude and azimuth is that these coordinates are the same regardless of position on Earth. So if you remember, the altitude and azimuth depended on where you are located. These are universal coordinates. They are the same for everybody on the Earth. The right ascension and declination will specify the location of an object exactly in the sky. Now we can look at that on another map here. Let's take a quick look at it in a different view. Here we see it in a global view. Here we see it on a flat map view. And we can then see that the right ascension and declination are measured from a specific object. So here from the vernal equinox, and you measure them as you go around. So the right ascension would be how far you are around here. So for this first star, that's its right ascension, and then up to it for its declination. For the second star, we would do the same thing, except it would be going a little bit farther along. So let's go ahead and look at that one. We go out here. It continues along the equator, and then in this case, it would be down to a negative declination. So the right ascension is always measured in hours, shown up here. The declination is measured in degrees above or below the celestial equator. So let's go ahead and finish up with our summary. And what we've looked at today is the equatorial coordinate system uses the two coordinates, which are the right ascension and declination, and that determines a position in the sky of any object. The declination is the object's angular distance north or south of the equator. The right ascension is the angular distance, which we measure in hours, eastward of the vernal equinox, or the positioning of the sun at the first day of spring. So that concludes this celestial sphere discussion on right ascension and declination. We'll be back again next week for another topic on the celestial sphere. So until then, have a great day, everyone, and I will see you in class.